In section 3.3, we will talk about zero, negative, and fractional exponents. So let's take an example of a zero exponent. If a is any non-zero real number, then we define a to the zero power equals to 1. In other words, anything to the zero power is always 1. So this is equal to 1, and this is equal to 1. So that's the easy case. Now let's take a look at the harder case where we have a negative exponent. Let's say we have a to the negative n and y that equals to 1 over a to the n. So here's an example. Let's say we have 2 to the second divided by 2 to the fifth. Using the formula, remember that if you have a to the m divided by a to the n, this equals to a to the m minus n, where we take the exponent of the numerator, subtract the exponent of the denominator. So according to this formula, we keep the base and we subtract 2 minus 5, which equals to 2 to the negative third. Another way to look at that is 2 squared. It means we have 2 2's on the numerator and 5 2's on the denominator. So what we can do at this point is we can cross these out. And when all the 2's are gone, we're left with the 1 on the numerator, and we have 2 times 2 times 2, which is 2 cubed on the denominator. So doing it one way gives you 2 to the negative third. Doing it a second way gives you 1 over 2 cubed, which means that 2 to the negative third and 1 over 2 cubed are equal to the exact same thing. Negative exponents happen when we have more on the denominator than we do on the numerator. So a to the negative n equals to 1 over a to the n. In other words, whenever we have a negative exponent, we flip it to the other side and it becomes positive. So here's an example. We have 2 to the negative third. This equals to 1 over 2 cubed, because if you have a to the negative n, it's always 1 over a to the n. In other words, to make an exponent positive, you move it to the other side. So if it's on the numerator, it goes to the denominator. And 2 cubed is 2 times 2 times 2, which is 1 over 8. Another example is we have 4 to the negative third times 5 squared. So notice that the negative 3, the exponent negative 3, it only belongs to the 4, not to the 5. And anytime an exponent's positive, it stays on the same side. But if an exponent's negative, then it moves to the other side and becomes positive. So because the 4 to the negative third is on the numerator, it moves to the denominator and it becomes positive. If you simplify this, 5 squared is 25 and 4 cubed is 64. Okay, next up we have 7 to the 0 power. So first off, anything to the 0 power is 1. And now here's what's going to happen. We have 1 x to the negative second, we have y to the negative fifth, and z squared. I am going to circle the terms that have a negative exponent, which is the x to the negative second and y to the negative fifth. Remember that anytime we have a negative exponent, that term is going to move to the other side and become positive. So the x to the negative second goes to the denominator and becomes positive. The y to the negative fifth goes to the numerator and becomes positive. So to make an exponent positive, you always flip it to the other side, and then the z squared stays where it's at. So this is going to be your final answer. Another example, I'm going to highlight the terms that have a negative exponent. That's the x to the negative second and y to the negative fifth. And then we flip them. So it's kind of the same thing as here, right? Except there's no 7 to the 0. So x to the negative second goes to the denominator, the y to the negative fifth goes to the numerator, and then we still have a z squared. So same answer, but without the 7 to the 0. Okay, here's another example. We have 6x to the fourth to the third power divided by x to the negative second. Now here, we do have to follow PEMDAS. So parentheses comes first, then exponents, then multiply, divide, then add, subtract. So the parentheses, it's fixed. There's nothing to do in there. So we leave it alone. The next step is going to be exponents. So for exponents, we take each individual term, so the 6 and the x to the fourth, and we raise them to the third power. This is from section 3.1, where if we have 2 terms inside of parentheses, and that whole parentheses is raised to the third power, it gives you 6 cubed and x fourth to the third. And then that's still divided by x to the negative second. Now we're not going to do anything yet until we get rid of the exponents. So 6 cubed is 6 times 6 times 6, which is 216. X to the fourth to the third power. Remember that if you have an exponent to an exponent, power to a power, you multiply those, we get x to the 12th, and we divide that by x to the negative second. And then lastly, we cannot have a negative exponent. So because this exponent's negative, it's going to flip to the numerator and become positive. So we have 216 x to the 12th, and this exponent that's on the denominator, it's going to flip to the numerator and become a positive 2. So nothing is left on the denominator, it's gone. Product rule for exponents says if you multiply the same base, we add the powers. So 12 plus 2, this gives us 216 x to the 14th power. Now let's take a look at the same type of example, except we have a positive exponent on the denominator. So we have 6 cubed, that's the same. We have x to the 4th to the 3rd power, that's the same. And then we have x to the 15th. So 6 cubed is 216, 4 times 3 is x to the 12th, and then we have divided by x to the 15th. Now here's where the difference comes in. I'm going to split this up as 216 times x to the 12th over x to the 15th. And remember that anytime you divide the same base, we subtract the powers. So I subtract 12 minus 15. And then this gives us 216 x to the negative 3rd. 12 minus 15 is negative 3. But we can't leave our answer as a negative exponent. So to make it positive, that negative exponent goes to the denominator, and it's going to become 216 x to the positive 3rd. Okay, next, write using only positive exponents. So first thing I'm going to do is I'm going to separate the 7 times 2, the y to the negative 13 times y squared, and then we have just a z to the 0. Now 0 to the 0, that's equal to 1, so that is not even an issue. 7 times 2 is 14, so that's easy. Here, we have y to the negative 13 times y squared. Remember that if you have a to the m times a to the n, if you multiply the same base, we are actually just adding the powers. So if I add negative 13 plus 2, this gives me y to the negative 11th. So I have my 14, that stays where it's at. The y to the negative 11th, that has a negative exponent. Only the terms with the negative exponent, they move to the denominator. So that's going to go to the denominator, become positive, and the 1 is just a 1. So this is my final answer. Okay, here's another example. We have 12 over 18, so let's separate everything. We have x to the negative 6th over x to the 5th. Then we have y to the 4th divided by y to the negative 2nd. And then we have z to the negative 3rd divided by z to the negative 6th. Now there are many ways of doing this problem. You can experiment with different ways, but I'll show you one way. And again, you can try a different way. So first off, you can reduce this. 6 goes into 12 twice, and 6 goes into 18 3 times. So this gives us 2/3. Now option 1 is to flip all the negative exponents to begin with. So anytime you have a negative exponent, I'm going to circle that. We're going to flip it, and it's going to go to the other side. So everything I've circled is going to flip. So when the x to the negative 6 goes to the denominator, in its place we have a 1. And then we have x to the 6th times x to the 5th. When y to the negative 2nd goes to the numerator, in its place we have a 1. When something moves and leaves nothing, there's always an invisible 1 there. And then we have y to the 4th times y squared, because it came from the denominator. So this goes down, this goes up. Now these two, the z to the negative 3rd goes to the denominator, becomes z to the positive 3rd. Z to the negative 6 goes to the numerator, becomes z to the positive 6th. So one method is to flip all the negatives immediately and only deal with positive exponents. So now, going this way, I have 2/3. X to the 6th times x to the 5th, that's going to be x to the 11th on the denominator. Y to the 4th times y squared, that'll be y to the 6th on the numerator. And then z to the 6th over z to the 3rd. Remember that when you divide the same base, we subtract the exponents. So 6 divided by 3 is 3, which means we have z to the 3rd on the numerator. Okay, next example. We have this parentheses raised to the negative 4th power. Remember that first thing we have to do is we take each individual term and raise all of them to the negative 4th power. So we have a to the negative 3rd to the negative 4th, b to the 5th to the negative 4th, and then we have c to the negative 3rd to the negative 4th. Now let's multiply. Negative 3 times negative 4 is positive 12. 5 times negative 4 is negative 20. And then negative 3 times negative 4 is positive 12. So step 1, take each individual term and raise all those terms to the negative 4th power. From there, I'm going to circle the term that has a negative exponent, which is a b to the negative 20th. And this gives me a to the 12th. The b to the negative 28th goes to the denominator, becomes b to the positive 20th. And then we have c to the 12th. Lastly, we want to write this using only positive exponents. So I'm going to split these up. Sorry guys, my computer froze. Let's see if it's working now. So I'm going to split these up, yes, as 2 times negative 6. Always split up the numbers and then the different variables. So we have a to the 3rd times a to the negative 2nd, and then we also have b to the negative 4th times b. If there's no exponent, there's like an invisible 1. Okay, now 2 times negative 6 is negative 12. So you can flip the negative exponents if you wanted to, or you can leave them like this. Since I did the flipping method up here, I'll do the non-flipping method here. So the non-flipping method is I add the exponents. So I add 3 minus 2. And then I add negative 4 plus 1. So this gives us negative 12. 3 minus 2 is a. And then negative 4 plus 1 is b to the negative 3rd. Can't have a negative exponent, so that's going to flip to the denominator. So the negative 12 and a stay on the numerator. The b to the negative 3rd goes to the denominator, becomes b to the positive 3rd. In class, I'll talk about a different way of doing this, but this is one way. The flipping method is the other way. You do whatever is going to work better for you.